Hello and welcome to our presentation. Our names are Mehusi, Savannah, Brianna, and Heidi. To begin with, we're going to talk about the Toms River case, which was located in New Jersey, and in 1990s it had families affected by cancer that was linked to industrial pollution. The populations most affected by the toxic chemicals in Toms River were residents living in the Dover Township during the operations of the Ciba-Geigy manufacturing plant, specifically families who resided in areas that obtained drinking water from the Parkway Wellfield and Pleasant Plain wells, and individuals with prolonged exposure to Toms River and the tourist beaches on the east coast where Ciba-Geigy dumped waste. The population seemed to be the most susceptible to the effects of the toxic chemicals from drinking water in Toms River were infants and young children. In 1952, Ciba-Geigy Industrial Manufacturing Plant was established in Toms River, and between 1952 and 1966, solid and liquid waste was legally dumped in about 20 different areas of the company's property, resulting in soil and groundwater contamination. During the days the plant was operating, over 5 million gallons of toxic waste were dumped directly into Toms River. In 1966, a 10-mile pipeline was constructed which dumped treated chemical waste directly into the Atlantic, lasting for 25 years. In 1965, toxic chemicals were discovered in drinking water, which was concealed from the public by the Ciba-Geigy Company and the Water Company of Toms River. In 1971, it was discovered that Union Carbide illegally dumped over 5,000 drums of chemical waste at the Reich Farm, which affected the Dover Township Municipal Landfill, private wells in Pleasant Plains, and several wells at the Parkway Wellfield, which were primary sources of drinking water for the residents in the area. In 1984, Ciba-Geigy's pipeline burst, and this started a 12-year process of bringing to light events that transpired in prior years. In 1990, manufacturing at Ciba-Geigy stopped. In 1996, cancer-causing agents were discovered in the water, and the wells affected were shut down. And in 2001, a 30-year plan was implemented to clean up the toxic chemical pollution in Toms River. Today, Toms River is clean from contaminants. Among the contaminants found in Toms River were trichloroethylene or TCE and tetrachloroethylene, which are substances commonly used as industrial solvents, and styrene acrylonitrile trimer and styrene acrylonitrile dimer, which are resins commonly used in containers and packaging materials. The source of exposure for TCE and styrene acrylonitrile was primarily found in the well water and drinking water in Toms River. The chemicals were dumped into Toms River, the Atlantic Ocean, and onto Reich Farm, which then contaminated the soil and underground water, eventually polluting well water, which was then used as drinking water in Dover Township by its residents. TCE and styrene acrylonitrile can enter the body through breathing, eating, or drinking, and by contact with the skin. The chemicals can also enter the body through inhalation, so factory workers at Ciba-Geigy could have been exposed. Short-term exposure of trichloroethylene may cause irritation to the eyes and skin. Exposure to high concentrations can cause dizziness, headache, sleepiness, confusion, nausea, unconsciousness, liver damage, and even death. Styrene acrylonitrile can cause similar symptoms to TCE if short-term exposure occurs. TCE is also a known carcinogen. Long-term exposure of TCE can result in damaging effects to the immune and reproductive systems, liver, kidney, central nervous system, and may affect fetal development during pregnancy. It also causes an increased risk of kidney cancer. Prolonged exposure to styrene acrylonitrile can irritate the nose, causing discharge, nosebleeds, and sores inside the nose. Some methods that could have prevented the incident in Toms River would be to not allow factories to dump solid or liquid waste near water sources or residential areas. There should have been also stricter laws and procedures implemented by the local health departments, EPA, and at government levels. The testing done on water in residential areas should have been done more frequently and should have tested for a wide range of chemical agents to ensure there were no carcinogens. When the cancer-causing agent TCE was discovered, immediate remediation plans should have been put in place. The wells contaminated should have been shut down. Carbon filters should have been established, and immediate procedures to remove toxic waste should have been implemented. Residents of Toms River should also have been made aware of the potential danger of consuming the water to make changes like starting to drink bottled water. Although Toms River was a disaster event for residents living in the area, there are many pros and cons to the actions that Ciba-Geigy and government agencies took. First, Ciba-Geigy did legally obtain permission for waste management disposal from 1952 to 1966. However, they did knowingly dispose of the toxic waste with no concern for the potential harm it could cause to residents in the area, and when the chemicals were discovered, they concealed the records. The government also played a role by allowing Ciba-Geigy to have a manufacturing plant with no strict regulations or continuous evaluations soils, and they also ignored early discovery of the chemical pollutants, which remained concealed from the public until concern broke out in the 1990s. The EPA did, however, order Ciba-Geigy to repay debts to the families affected by the chemical waste and to pay for the damages and the cleanup process in Toms River. To date, Toms River is clean from contaminants due to the 30-year plan put into effect in the late 90s, early 2000s. For part 2 of our project, we chose Torch Lake, Houghton County, Michigan, as a similar case to Toms River. Torch Lake is located on the Keweenaw Peninsula of Houghton County, Michigan, and was home to copper mines, smelters, mills, and beneficiation processing from 1868 until 1969. During this time, more than 5 million tons of copper were mined from the Keweenaw Peninsula, half of which was produced along the shores of Torch Lake. The main copper mining smelter on Torch Lake, Calumet and Helka Smelting Works, was constructed in 1886. During this time, mill tailings, slag, and stamp sands were produced. These are coarse waste materials that come from the separation of copper from rock during the mining process, and they were disposed of on the shorelines of Torch Lake and contaminated the shorelines. At one point in time, 50% of Torch Lake was filled with stamp sands. Smelting is very dangerous, and stamp sands contain toxic metals like copper and arsenic. If any of these metals or toxins are inhaled over time, they can cause lung diseases like silicosis. Stamp sands are also harmful to plants, fish, and other small organisms. In the 1970s, fish in the lake were found to have tumors, and this led to consumption advisories. In 1984, Torch Lake was officially declared a Superfund site and was listed on the Areas of Concern list in 1985. In 1992, cleanup on Torch Lake began with the EPA covering stamp sands with soil and vegetation. In 1994, the EPA switched to a no-action plan for the area, but after further investigation, they determined that the area was in need of more construction. In 1999, construction to cover the stamp sands was started, and it finished in 2005. Today, approximately 4,000 people live within a mile of the lake. Torch Lake is used by residents for boating, swimming, and fishing, and it's also frequented by tourists. Groundwater from the area is also a source of drinking water for the residents. The Michigan Department of Community Health noted that private residential wells may have also been installed or constructed in stamp sands. Those who are frequent to the area and employees of the smelting company were at risk of health effects if they ingested or touched contaminants of mill tailings found in sediments, soil, or groundwater. Employees were also at risk as they inhaled dangerous metal dusts, fumes, and combustion gases. The mining industry processed metal-rich ore for years, which left behind metal materials that can harm both humans and wildlife. Metals such as copper, arsenic, chromium, mercury, and lead can be found along Torch Lake at quantities that exceed the Michigan Part 201 criteria shown in the map to the right. The contaminants around the Torch Lake can cause many health effects. There are known carcinogens like PCBs linked to cancer and diabetes, endocrine disruptors like cadmium, which can result in kidney damage, neurotoxins that come from consuming contaminated fish and can lead to central nervous system damage, persistent bioaccumulative toxins, reproductive toxins, volatile organic compounds like lead, which causes central and peripheral nervous system damage, and mutagens found in the area causing gene mutation and irreparable DNA damage. The contaminated sediments in Torch Lake are believed to be 70 feet thick in some areas and are saturated with copper. Copper is a common metal element found in the environment, in air, water, sediment, soil, and rock. It is also commonly found in food and drinking water in small amounts, but in large quantities it can be harmful for the body. Copper was found in the shorelines and sediment in Torch Lake and entered the body through inhalation or ingestion of contaminated air or water. Prolonged exposure to copper particles can cause skin problems. Metal fume fever is also commonly associated with copper exposure. Symptoms include irritation of the eyes, nose, and throat, dizziness and nausea, and they can typically resolve after 24 to 48 hours of avoidance. Copper toxicity or poisoning can also result from prolonged exposure to copper, resulting in headaches, nausea, hematemesis, melena, and a metallic taste in the mouth, as well as the other symptoms shown in the graphic on the slide, like convulsion, decreased liver function, and diarrhea. Long-term effects of copper exposure and copper toxicity can cause liver damage as well as copper pooling in the brain and eyes. Routes of exposure to mercury and lead in the case of Torch Lake include eating contaminated fish, direct physical contact with metal-rich soils and sediments, breathing in air filled with metal-rich dust, and ingestion of metal-rich soils. There are limitations on the consumption of certain fish from Torch Lake due to high mercury concentration. Mercury in Torch Lake fish has been found that it's around more than 0.3 milligram per kilogram since 1988. Mercury can cause loss of peripheral vision, muscle weakness, pins and needles feelings in the hands, feet, and around the mouth, impairment of speech and hearing, as well as lack of coordination. In addition, mood swings, irritability, tremors, insomnia, poor mental function, and headaches can also happen. Lead, on the other hand, can put pregnant women at risk of miscarriage and subject the fetus to developmental issues. It can also cause learning and behavioral issues, hinder growth, anemia, lower IQ, and hyperactivity in children. It can also cause reproductive issues in men and women and disrupt the cardiovascular system and decrease kidney function. Steps such as stabilizing soils containing metals or chemicals to prevent unwanted metal releasing to the environment and preventing water contaminations, as well as controlling the air emissions, could have prevented the damages that were done to the Torch Lake area. Soil treatment can be done using chemical methods to stabilize metals in soils, making them less mobile and biologically available. Using bioliners as barriers at the base of waste piles can also contribute to soil treatment. Permanently floating waste materials containing pyrite to cut off the source of oxygen can stop the development of acidic conditions and prevent mobilization of metals. Water treatments include using limestones as neutralizing agents, using passive wetland systems that contain soil, plants, and microbes to maintain desirable wildlife habitat, creating in situ treatment zones that use electric currents and reactive materials to clear water of contaminants. Additional processes that could have been used to prevent what happened in the Torch Lake area include preventing acid rock drainage and controlling gas emissions. Acid rock drainage can be done by floating off old underground mine workings, sealing exposed surfaces with material that is non-reactive or impermeable, and backfilling mine workings with reactive materials. The control of gas emissions could have been done through the use of modern technology and following guidelines on the recommended levels of emission while using technology that is eco-friendly, which can lead to better air quality. Good actions taken by Calumet and Hecla companies at Torch Lake included the starting of reclamation, which consisted on recycling copper. On the bad side, reclamation of scrap materials, though it meant recycling, it also generated profit, and it also resulted in additional toxic waste generation in the area. Lead and zinc wastes were produced in addition to volatile PCBs that deposited in the soils. The company closed due to strikes in 1968 after 100 years of operations, and it never reopened again. No cleanup efforts were made on their part. Among the cons the government had, we found that in 1891, the U.S. government took over the Keweenaw waterway, but it excluded Torch Lake from the provisions of the act. No harbor lines were designated for Torch Lake, and no clause on dumping was applied. Consequences for stamp sand disposal were drastically different between Portage Lake and Torch Lake. Dumping of mine wastes was still legal until the 1970s. The good part on the government actions included the EPA contributing to several aspects of cleanup, removal, and remediation, including the Superfund cleanup program, which was initiated in 1980 for covering and revegetation of stamp stands. The Michigan Department of Environmental Quality's Office of the Great Lakes is cleaning up water pollution from past mining activities within Torch Lake. The Remediation and Redevelopment Division is conducting ongoing investigation on mining sites, identifying all sites with hazardous substances at high concentrations, and working with the EPA to implement remediation actions. Thank you very much.